Okay, I guess we have to start class at some point, huh? Welcome everyone. Glad you're here. Don't forget to turn on your camera so I can see your smiling faces, and we can get into this review for the exam, which will be tomorrow. It'll open at 11 a.m., close at midnight on Canvas. It's an 80-minute exam, okay? And check your email for some more details about it in terms of what you can bring and what you can use, okay? Before we get started, do you have any questions for me? Sophia? Sophia, I think you're on mute.
Oh, sorry. I just have a general question about a problem. Should we do that after, or can I ask it
Yeah,
now?
let's do that after the review, if that's okay.
Yeah,
Just remind me afterwards, yeah. Taylor?
Just a problem on a question on the problem set. I see the one that's due yesterday. You can hit practice mode on it, but for the exam, the pre-exam, you can't. Is there a way of hitting practice? Just off curiosity.
You mean for the pretest?
Yeah, for the pretest.
I think it has to be past due before you can do practice.
Oh, okay.
Yeah.
Okay, that kind of makes sense. Okay.
There are some extra practice problems in the study area. Have you tried those?
Yeah, I got those.
Okay.
I just noticed it. I was just curious if there was something I'm missing. So
Yeah, no, I think that's the only way is after it's, I don't think it'll let you practice while it's still before it's due, unfortunately.
okay. Thank you.
Yeah, good question though. If there's a way to do that, I will try to see if I can figure it out. Have you completed it and turned it in?
Yeah, I completed and turned it in.
And it
So
still
it
won't
might
let you
be
practice, right?
Mm-hmm.
Yeah. Okay. I think it has to be past due.
Okay.
All right. Any other last minute questions here before we get going? Okay. Let's do a quick review, and then we'll have a question and answer session for as long as you guys have questions. Okay. So this exam will cover chapters 16, 17, and 18. Can everybody hear me okay? Sounds good. Okay. It'll cover chapters 16, 17, and 18, which has been, like I said, the toughest topics that we've had so far. The good news is that it gets a little bit easier after this. So that's kind of nice. And so there's a lot of different equilibria in here. And the first chapter started by introducing equilibria, right? So remember, we started by defining the equilibrium constant, right? So I want you to, of course, know the definition of that. We talked about dynamic equilibrium, right? When the rate of the forward reaction equals the rate of the reverse reaction, that's when you've reached equilibrium, right? And at that point, the concentrations of the reactants and products no longer change, right? They become constant. And that state is described by the equilibrium constant expression, right? And the equilibrium constant K, all right? Remember that things like remember that pure solids and pure liquids are left out of the equilibrium constant expression, right? You just include things that are aqueous and things that are gas, okay? But solids and liquids are not included. We learned how to calculate K, right? If you have measurements of the equilibrium concentrations of the reactants and products at equilibrium, then you can plug those into the equilibrium constant expression, right? And you can get K. We talked about the reaction quotient. The reaction quotient, right, is identical to the equilibrium constant in terms of the way you express it. The only difference is that the reaction quotient can be expressed at any point in the progress of a reaction, right? So it doesn't have to be at equilibrium. So K at a given temperature just has one value, right? But Q can have many values, right? And Q tells you where you are relative to equilibrium, right? If Q is less than K, then you know the reaction is still going towards products, right? If Q is greater than K, then you know that the reaction is going towards a reactance. And if Q is exactly equal to K, then you know that the reaction is in equilibrium. Okay. Then the big topic of this chapter, finding equilibrium concentrations, right? Which you've been doing now for 3 weeks. And there are two types of problems, sort of the more simple problems where you know K and you know a bunch of equilibrium concentrations except for one, right? And then you just solve the equilibrium constant expression for that one that you don't know, and that gives you the concentration of that. But the more typical kind are the ones where you're given K and initial concentrations and asked to find final concentrations. And those are the problems, of course, where you have to write an ice table, right? Fill out the ice table, solve for X, right? Sometimes it requires solving a quadratic, all right? You can use on the exam, you can use a quadratic solver, all right? But look for shortcuts. I guarantee you there'll be a lot of shortcuts in terms of quadratics. And the main shortcuts to look for are perfect squares, right? When you have, you know, some expression like, let's say, x squared over 0.5 minus x squared equals k, right? When you come up with an expression like that, you might think, oh, I have to solve a quadratic to solve that, but you don't, right? Because the top and the bottom, because this is equal to x over 0.5 minus x to the quantity squared, right? You can just take the square root of both sides. And that becomes much easier to solve, right? You don't have to solve a quadratic that way, all right? So look for those kinds of shortcuts. And then, of course, look for the x is small shortcut, which you'll see a lot of on this exam, okay? For all buffers, you can assume that x is small, and for all buffers, you can use the Henderson-Hasselbalch equation, okay? Okay, and then know about Le Chatelier's principle, right? What happens to a system at equilibrium when you change A, concentrations of reactants or products, B, the volume, C, the temperature, and D, when you add an inert gas. All right, an inert gas is a gas that's not participating in the reaction at all. And the effect of an inert gas is zero, right? Adding an inert gas doesn't do anything to the reaction. It doesn't shift it in either direction. Okay. Sophia.
I've been using the quadratic formula on my calculator, but for checking if the x is small is valid, we had to divide the concentration that we got by the original and multiply by 100%.
Correct. Yeah. So if you're making the x is small approximation here, for example, right, whatever you get for x, you divide by 0.5 and multiply by 100%. And if that's less than 5%, then you're fine. Okay.
Thank you.
Good question. Any other questions? Okay, very good. As you know, at the end of every chapter in the book, there's a list of key skills, right? And this is a good sort of check mark for you. Do I know how to do this? Do I know how to do this? Oh, wait, I don't know how to do that. Here's an example that shows you how to do that kind of problem. And here are some exercises that you can do. These 4 practice problems are particularly nice. They're found right after the example, and the answers to them are found in one of the appendices in the book, right? So you can always work those for extra practice as well, okay? But this is a nice checklist of all the different skills that you need to know. So write an equilibrium constant expressions, right? Just being able to take a chemical equation and write an expression for K from that equation. Know how changes in the chemical equation affect the equilibrium constant. So for example, if you multiply an equation by 2, what do you do to K?
Square it.
Square it, right? If you reverse an equation, you take the inverse of K, right? And if you have 2 equations who they can add up together to form a third equation, then K for that third equation is the product of the K's for the first 2 equations, Be able to write equilibrium constants in terms of partial pressures or concentrations, right? So remember for substances in solution, you can only do Kc, but for gases, you have the option of expressing that in Kp or Kc. A lot of times the problem will dictate which one you use because it'll either give you Kp or Kc, and you have to just go with that. Be able to, in addition, convert I think I just broke up. Can you still hear me? In addition, you have to be able to convert between Kp and Kc. Okay. Write equilibrium constants for chemical equations that contain solids and pure liquids. So just remember, solids and pure liquids are left out of the equilibrium expression. Right? Calculate equilibrium constants from experimental concentration measurements, right? So if you know the concentrations of all the reactants and products at equilibrium, you can just substitute into the expression for K, and you can find the value of K. Predict the direction of reaction by comparing Q and K, right? And we already went through that a little bit. If Q is less than K, the reaction is going to the right. Q greater than K, it's going to the left. Q equal to K, it's at equilibrium. Calculate unknown equilibrium concentrations from known equilibrium constants in all but one of the reactants and products equilibrium concentrations, right? So that's the case where you have some reaction. Let's say you have an equilibrium constant, concentration of B, concentration of C over concentration of A, right? And if you know K and you know any two of these, you can get the third one, right? Calculate unknown equilibrium concentrations from known equilibrium constants and initial concentrations or pressures. Okay, that's the ice table problem, right? And you've done a lot of those, but make sure you know how to do them. Make sure you know how to set them up, right? And solve them. This one is in cases with a relatively small equilibrium constant, and so this is just basically know how to use the X's small approximation when it's relevant. Okay, and then these last three things are.
Troy, I have a question real quick about the I think it was 16.8. So if you're calculating the equilibrium concentration from like pressure, do you have to use Kp?
Yes.
Okay, thank you.
If you're calculating the equilibrium partial pressures.
Equilibrium
when
pressure.
you're using Kp, you're always working with partial pressures. When you use Kc, you're working with molarity.
So like if you were to do an ice table with the pressures, you'd be using Kp.
If you did an ice table and you were given pressures, you can just put pressures into the ice table. Yep. The pressures have to be in atmospheres though. Okay.
Okay.
Okay, and then these last three are basically predicting effects based on the Chatelier's principle, right? So changing the concentration, changing the volume or pressure, and then temperature change. Okay. All right, what are the important equations you need to know for this chapter? Well, you need to know how to write the equilibrium expression, of course, right? These are not really equations, but they're what happens to the equilibrium constant if you reverse the equation, multiply by coefficients or adding them, right? This is just the expression for Kp, right? So notice Kc is in concentration units, Kp is in atmospheres. And then this is the relationship between the two, right? So if you know Kc, you can get Kp and vice versa. This delta N is the difference in the stoichiometric coefficients between the reactants and products, right? So you take, if you have a reaction, let's say 2A goes to B plus 3C, right? Then delta N would equal to 4 minus 2 equals 2. right? It's the sum of the coefficients for the products minus the sum of the coefficients for the reactants. The reaction quotient Q, right? Notice it has the same definition as K, except for that these concentrations can be at any point in the reaction, not just at equilibrium. All right. And then the same thing for QP. And then finally, the relationship between Q and K. If Q is less than K, the reaction is going to the right. If Q is greater than K, it's going to the left. And if Q is equal to K, the reaction is at equilibrium. Any questions about chapter 16? Okay, good. Chapter 17 is a chapter on acids and bases. So know the general characteristics of acids and bases, such as acids taste sour, right? Bases taste bitter, those kinds of characteristics that we talked about. Know the definitions of acids and bases, just two definitions that I want you to know, the Arrhenius definition, right? And the Bronsted-Lowry definition. And know about acid strength and the acid dissociation constant, right, which is Ka. You don't have to memorize values of Ka or anything like that. They'll be given on the exam as needed, right? But you have to know how to use it, right, and understand, and then also know the 6 strong acids, right, that I asked you to know: HCl, HBr, HI, HClO4, HNO3, and H2SO4. Okay, those are the 6 strong acids. And just know that if you see those, know that they're strong. Be able to find the pH of strong and weak acid solutions, right? For strong acid solutions, just equal to the concentration of the acid is the hydrogen ion concentration, then take minus the log of that. For weak, you have to solve an equilibrium problem. Base solutions, same thing. Be able to find the pH of strong and weak base solutions, all right? And then lastly, the acid-base properties of ions and salts, right? So know that cations can sometimes be acidic, anions can sometimes be basic, and know how to recognize those, okay? And also know how to find the pH of solutions containing those, right? So in those cases, for example, if you have a base, an ion that's a base that's acting, if you have an ion that's the conjugate acid of a weak base, so it's an ion acting as an acid, right? Then to get Ka, you need to use the expression Ka times Kb equals Kw, right? So make sure you know how to do that. Okay, let's see. Be able to understand the different definitions of acids and bases, perform calculations involving Ka and Kw, right? Know how to calculate pH, know what pH neutral is, what's acidic, what's basic. Be able to perform pH calculations or calculate the pH for strong and weak acids. Calculate the percent ionization for weak acids. You know what, actually, this one, you don't have to, you won't have to do this. Well, I mean, yeah, actually, there's a sense in which you do. So let me not totally cross that out, because you kind of have to do that like on a pH titration. So what I mean here, calculations of mixtures of acids. If you have a strong acid and a weak acid, you can ignore the weak acid and just focus on the strong one. If you have a strong base and a weak base, you can ignore the weak base and just focus on the strong one. Okay, that's all I really mean by this. So don't worry about doing anything else for mixtures. Okay. But you know, that's the case you have, for example, at the end point of a titration in which you're titrating a weak acid with a strong base, right? You have a mixture of the two, and you just focus on the strong one every time. pH calculations for strong bases and weak bases, right? Again, look at anions and and classify them as basic or neutral. Be able to do calculations to solve the pH of those anions. Similarly for cations, acidic or neutral. And then classify salts as acidic, basic, or neutral. All right. And then these last 4 sections, we did not really cover much, and they will not be on the exam. All right. So polyprotic acids will not be on the exam. Molecular structure will not be on the exam, and the Lewis model will not be on the exam. Okay. So those things you don't have to worry about. Okay, chapter 17, key equations, right? The expression for Ka, the ion product constant for water, right? Make sure you have this written down so you know what that constant is, because that constant is not given on the table of constants, right? But you get to use a cheat sheet, so just make sure you know that equation. Expression for pH and pOH, right? Be able to calculate those. Know that the sum of pH and pOH is equal to 14. So if you know one, you can easily calculate the other. pKa minus the log of Ka, right? Percent ionization is the H3O plus concentration at equilibrium divided by the initial concentration of the weak acid, right? This percent ionization for strong acids is how much? Is what?
Nearly 100%.
100%, right? It's 100% for strong acids, right? And it's usually under 10% for weak acids, okay? And then lastly, Ka times Kb equals Kw. Abe, question.
Yeah, I just had a quick question are we gonna have to know the first ionization step for the exam?
Are you gonna, I'm not
Like
sure
when
what you mean.
Like when we need to write a chemical equation for the first ionization step of an acid.
Well, yeah, I mean, that's this equation right here, right?
Oh, that's just that. Oh, yeah. Okay,
Yeah.
cool.
I mean, I think you're talking about a polyprotic acid, maybe.
Yeah.
You don't have to know anything about, you don't have to worry about polyprotic acids, just the ionization of a monoprotic acid, which is this equation right here.
Oh, okay, okay. Got it. Thank you.
Yeah, you're welcome. Okay. Chapter 18, buffers. So of course, know what a buffer is, right? Know how to calculate its pH. Know about buffer range and buffer capacity, right? Remember that a buffer, you can make a good buffer based on an acid and its conjugate base. If you know pKa for the acid, you could make a buffer within 1 pH unit of pKa. So for example, if pKa is 5, right? The buffer range would be 4 to 6, right? 1 pH unit on either side of that. Buffer capacity refers to how much acid or base you can add to a buffer before you destroy it, right? So the number of moles of base you can add to a buffer before you destroy it is equal to the number of moles of weak acid that's in the base. Sorry, that's in the buffer, right? So for example, if you have a buffer that contains 0.10 moles of some acid HA and 0.15 moles of some of the conjugate base A minus, right? You can add 0.1 moles of base to this buffer before you destroy it. You can add 0.15 moles of acid to this buffer before you destroy it. Okay. Then the big one, titrations and pH curves, right? So be able to calculate those points along a titration, both for when both the acid and base are strong, or when one of them is strong and the other one is weak. All right. And then finally, solubility equilibria and the solubility product constant. Just 2 things for this. I just want you to know the concept, right? And if you know Ka for some soluble for some ionic compound, be able to find the solubility from Ka. All right. All right. So pH calculations for buffer solutions. And you don't really have to do it with it. This is kind of do it with an ice table and do it with Henderson-Hasselbalch. You can always do it with the Henderson-Hasselbalch equation. Okay. So as soon as you recognize you have a buffer, just go straight into that equation. Be able to calculate pH changes in buffers when you add acid or base to the buffer. All right. So adding the acid to the base is going to change the relative amounts of the two components. Right. Be able to calculate that change and calculate the new pH. So this is for a weak acid and a conjugate. Yeah, same thing here, just for a buffer of a weak base and its conjugate acid. Just basically know what a buffer is and how you would make it. Be able to perform pH calculations for titration, strong acid, strong base, weak acid, strong base. Okay. Or weak base, strong acid. I want you to know both of those. You don't have to worry about this. This is polyprotic acids. You don't have to worry about that. You don't have to worry about indicators. KSP, like I said, all you have to know about KSP is what it is, how it's defined, and then be able to use KSP to get solubility. All right. And then the rest of these things you don't have to worry about. Okay. Then equations, the Henderson-Hasselbalch equation, of course, effective buffer range, pH, pKa plus or minus 1, and then the relationship between Q and KSP. And that's just the same as the relationships between Q and K, right? Same thing. Okay, very good. Questions, comments, curses. I'll take a couple questions and then I will dismiss you, and those of you that want to stay for more questions can stay. Are there any general questions before let's do this. See if there's any, let me see if there's any general questions. If there's general questions, I'll take those. If there's problem specific questions, I'll wait till I dismiss everyone. Okay. Emmanuel. Manny.
For the titration curve graphs, are they going to be similar to the ones we did on the problem set?
Of course, yeah.
Yep. Like just answer questions like that?
Yep.
Okay, cool.
Yep. It'll be, you have a titration. It'll give you the concentrations of the acid and the base, right? And then ask you to find things like where's the endpoint? What's the pH at 5 milliliters? What's the initial pH? What's the pH at the endpoint? Those kinds of things. Taylor.
For the KS, for the solubility equilibrium, there was one on the problem set from yesterday that had the solution with some other ion in it that was part of those. You need to do like an ice, like that, and then nothing else, right? Or
right. Well, that's the common ion effect, right? And I did have one like that for you on the problem set, but that will not be on the exam.
Oh, okay. Oh, I see it now. Okay, now I see it. Okay, thank you.
Yeah. Any other general questions? Okay, very good, very good. So remember, don't stay up late tonight. Get a good night's rest. Make sure you're rested when you take the exam, right? That'll be important. The time is going to be tight. I'm just warning you, right? So that's why I think it's good to just be rested and being able to think clearly and just do your best, okay? And don't compromise your integrity by cheating, right? You're just cheating yourself. So the exam is timed for that reason, right? And so if you start looking for things online, you will not be able to get through the exam. You have to know it pretty well, okay? So practice, practice, practice. Get a good night's sleep. And I I will see all of you on the other side of the exam oh no, not next Monday, because next Monday's spring break. Woo! So just think of that, right? You finish this exam tomorrow and you're done with chemistry for a week and a half. I see some smiles. All right. Thanks, you guys. Thanks for your attention. Thanks for your dedication to this class, and thanks for your hard work. I'll stick around to answer additional questions, but if you don't have any, you're free to go. Good luck on the exam tomorrow. See you all after spring break. Okay, I'll go ahead and take any questions now. Just use the raise hand function. Okay, Sophia.
So my question was about problem. What is it? 3, 4?